Figure 7 shows a sketch of the curve with the equation y equals 4x e to the minus 2x, where x is greater than or equal to 0. The line L is normal to the curve at the point P, which is 1, 4 e to the minus 2. The finite region R, shown shaded in figure 7, is bounded by the curve, the line L, and the x-axis. Excuse me. Find the exact value of the area R. So my method for this is I'm going to integrate the curve from 0 up to the x-coordinate of 1, and that's going to tell me all of this area here. Then we'll work out the area of this little triangle and take it away. So we are going to integrate between 0 and 1 the 4x e to the minus 2x with respect to x. Now to do this, we're going to need to use integration by parts. So I'm going to let u be equal to the 4x, and I'm going to let v dash be equal to the e to the minus 2x. Differentiate the 4x, integrate the e to the minus 2x, and then apply the by parts formula. So we're going to get u times v, so that's this times this, so I'll get minus 2x e to the minus 2x, minus the integral of u dash times v, so that's this times this, so that's minus 2 e to the minus 2x. Now to make that integral easier, I'm going to take the minus outside, the double negative. And now this will integrate easily. The exponential will integrate to be the exponential, and dividing by the minus 2 will give that as my answer for the integral. And the limits for the integral are between 0 and 1. So substituting the 1 in here, we'll get minus 2 e to the minus 2 minus e to the minus 2. That's substituting the 1 in, and now substituting the 0 in, we'll get the minus 2 times 0, and the minus e to the power 0, which is minus 1. So the area is going to just be a positive 1 and a minus 3 e to the minus 2. Right, so that's the area of all of this. Let's now work out the area of this triangle that we need to take away. So let me use a different colour for that. So this triangle here, now I can see the height of this triangle is 4e to the minus 2, but I'm not quite sure what the base of the triangle is yet. In order to know that, I need to know what this coordinate here is. And that's where this line L intersects on the x-axis. So if I can work out the equation of that line L, I can get that point. Now, line L is the normal to the curve. So if I differentiate my curve, then I can get the gradient function, and then I can work out the equation of the normal. Now, to differentiate this, we need to use the product rule. So I'm going to say u is equal to 4x, and v is equal to e to the minus 2x. So u dash will be 4, v dash will be minus 2e to the minus 2x. And applying the product rule then, I'll get dy by dx is equal to u dash v plus v dash times u. So timesing these two together will actually make this a negative 8x e to the minus 2x. So this is the gradient function, which at the point when x is 1, so if I substitute 1 into this, that's going to give me the gradient of the curve at that point. So I'll get 4e to the minus 2 minus 8e to the minus 2, which is minus 4e to the minus 2. So that would be the gradient of the curve at that point, or the gradient of the tangent at that point. But I want the gradient of the normal, so I want the negative reciprocal of that. Now, just to help me do the negative reciprocal, let me write this e to the power minus 2 in this form, because that minus 2 there means it's just e squared on the denominator. And now it's a bit easier for me to do the negative reciprocal there, so I'm just going to take that minus 4 and make it a positive, and flip that upside down, so I'll get e squared over 4. So that's the gradient of my normal. I can now do y equals m x plus c, and I know it's going through the point 1, 4e to the minus 2. So if I substitute that in, so the y is 4e to the minus 2 when the x is 1. If I solve this equation then, so if I times through by 4, and I'll subtract the e squared from both sides. And if I divide through by 4 actually, then that will give me my c. So I have now got my full equation of the normal. So I can now use this to work out this coordinate here, which I know is when y is equal to 0. So if I make my y 0 here, times both sides by 4 to get rid of those fractions. Let me add the e squared and subtract the 16e to the minus 2 from both sides. And then if I divide both sides by e squared, which I can simplify that a little bit because the e squared divided by the e squared will just be 1. And the e to the minus 2 divided by e squared will be e to the minus 4. So that is my x coordinate here. Which means that the base of my triangle here will be 1 take away the 1 minus 16e to the minus 4. So 1 minus the 1 minus 16e to the minus 4 will just be 16e to the minus 4. And like we said before, we know the height of this triangle is 4e to the minus 2, so the area is half base times height. Which gives 32e to the power minus 6. And to finish off then, we've got the integrated area. Take away our triangle, so shaded area R is 1 minus 3e to the minus 2 minus 32e to the minus 6. And that's my answer.